the magnetic field on the axis of a current loop. Current loop is a current loop. Let us say it is having a small current element dl and it has got a center. Let us call this center as C, and this is going to be having a distance which is equal to radius. I am going to write that radius equal to as capital R. So this is the radius of this circular current loop, the axis of this circular current loop. Here is where we are going to calculate our magnetic field, that is going to be our point P. Now from this dl, if you look carefully, this circle, it is like this, it is coming out of the board, then it is going into the board. It is like a three-dimensional circle. We are going to have the current flowing in this direction, in this way, and similarly we are going to have a current flowing in this point P. The magnetic field will be produced by this current element at this location. At this point P, it is going to be something like this. This is going to be the direction of the magnetic field which is going to be produced at point P due to the element dl. Now we need the distance between these two. Now this point P is at a distance of x from C. So C to P, the distance is, we are going to take it as x. Now I want the distance from this dl to this point P. Let's take this as small letter r. Now we are going to apply the Biot-Savart's law to find the magnetic field dB due to this element dl. So what is going to be? It is going to be dB equals mu naught by 4 pi I dl sin theta divided by r square. Since angle between dl and r is 90 degree, implies sine of 90 degree is equal to 1. That is dB equals mu naught by 4 pi into I dl divided by r square. Now that r square will be equal to x square plus r square. What is this? This Pythagoras theorem. dB will be equal to mu naught by 4 pi I dl divided by x square plus r square. Okay. Now the same current will flow here and it will go into the board at this point. We can take another dl element here, and when the same current flows into this dl, there will be another magnetic field produced at this point P. And what will be the direction of that magnetic field? I'll just take it here, and that direction is going to be like this. We are going to take the horizontal component and we are going to take the vertical components. So horizontal component, let's take it as dBx for the upper vector, and this is going to become dBy. So this is the horizontal component, this is going to be the vertical component, and this is for the upper part. It will be again, this is be dBx. Take the vertical component by dBy. The vertical components are equal and opposite. These two will cancel each other. It will cancel out. What is left is only the horizontal component. The magnetic field at point P will also be due to another current element dl at diametrically opposite point, another dl here, and that is going to produce this magnetic field dB. Now what happens? The vertical components of dB will cancel each other, and what is left is only the horizontal components, and horizontal components are left, and this angle we are going to take it as phi. Whatever the angle it is going to be appearing here, the same angle is going to appear here between this small letter r and this capital letter R. So I can write that angle phi inside the triangle dbx. So what is dbx? dbx is equal to db cos phi. As cos phi is equal to r divided by r. Cos phi is equal to r divided by x square plus r square whole to the power of 1 by 2. dB, the value is here, that is mu naught by 4 pi into I dl divided by x square plus r square into r divided by x square plus r square to the power of half. So that is my equation. dbx is equal to mu naught by 4 pi I dl divided by x square plus r square into r divided by x square plus r square to the power of half. So mu naught by 4 pi remains as it is. I will take r first, then it will be dl divided by 3 by 2. So it will be x square plus r square to the power of 3 by 2. Getting dl over the circumference. Of the circle. So to get the complete magnetic field, that will be the integration of dbx, and that will be the integration of this complete expression mu naught by 4 pi I r dl divided by x square plus r square to the power of 3 by 2. dl inside the integration. So it will be mu naught by 4 pi into I r divided by x square plus r square to the power of 3 by 2 integration of dl. Integration of dl will be equal to 2 pi r, that is the circumference of the circle. So I can directly take this value from the integration of this dl and substitute it there. So mu naught by 4 pi I into r, 2 pi r divided by x square plus r square to the power of 3 by 2. 4 pi ada 2 da, ಇಲ್ಲಿ 2 pi ada 1 da. So ಇಲ್ಲಿ r ಮತ್ತು r multiply agandre it is going to become r square. So what we are left here is mu naught I r square divided by 2 ಇಲ್ಲಿ ada into x square plus r square to the power of 3 by 2. So this is the general equation of the magnetic field on the axis of a current loop.